So now we're going to look at some graphical interpretations of velocity problems. So here on number 59, by taking the slope of a curve at figure 2.6, verify that the velocity of the jet car is 115 meters per second at t equals 20 seconds. So here I have a graph of position versus time, and at 20 seconds, this is figure 2.6 here. What I want to do is I want to estimate this slope here. And the way I would do this is I need a shape, I need a line that sort of goes. The idea is I would match the slope right there. I don't know, that's pretty good. And so what I would want to do is I would want to calculate what the slope of this line is. So the easiest thing to do might be to say, well, at times 10, I'm at 500, so this is the point 10, 500, and say this point here, you have to do this a lot on the AP exam. We'll say it's about 25, 2000. So the slope of the position versus time curve is a velocity, is the velocity. So we would say it's 2,000 meters minus 500 meters divided by 25 seconds minus 10 seconds. And so that's 1,500 meters over 15 seconds. And so I got, in this case, 100 meters per second, but that's probably because I didn't quite get it. If I had it on paper and I had a ruler and stuff, maybe I could make it exactly. Maybe the slope's a little flat. Maybe it should be a little bit steeper. But that's the basic idea. By taking the slope of any curve at point 2.61, verify that the acceleration. So here's the velocity as a function of time. If I take the slope of this, it should be the acceleration, right? And so the slope, the idea is, remember, the velocity is equal to the initial velocity plus acceleration times time. If time is my independent variable, my x-axis, and velocity is my y-axis, then a is our slope. And so if I look at this slope, I can calculate a. So let's take a couple of points. Let's say this is 5 and 40. And say this is 30 and, I don't know, 170. Or maybe this point would have been easier. 25 and 140. Yeah, let's use that point instead. And so the acceleration is just the slope of this line, 140 meters per second minus 40 meters per second, divided by 25 seconds minus 20 seconds. And this is 100 meters per second on the top, divided by the bottom here, which is 5 seconds. That's 20 meters per second squared. Okay, so I forgot to turn on my highlighter. Hopefully you can see that okay. Okay, so then using approximate values, calculate the slope of the curve in this figure and verify that the velocity is, so here again is a position versus time, and at 30 seconds we're going to estimate the slope like here through this here. And so estimating that slope is just to say, well, let's say this is a line. We'll say at 40 we're at like 12, so this is 40, 12. And then the point here might be 20 and like 7.5. So then the slope again would equal velocity, and that would be 12 meters minus 7.5 meters divided by 40 seconds minus 20 seconds. And so this is 4.5 divided by 20. What's that? 0.225 meters per second, because this is meters and this is second here. Okay, and so like that's close. Like you can't get exact. I don't know this getting this exact value, but verify it's around that. Like it's about that. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.